years. So I'm very happy to have with us Radovan Kopecek. He's the Managing Director, Advanced Cell Concepts, and a member Executive Committee member of the Executive Committee of ISC Konstanz, one of the leading research solar institutes in Europe. And while many of you probably, as I already mentioned before, have heard Radovan usually talk about IBC cells, we are very excited to have him today talk about the new TopCon process developed at ISC. Radovan, the floor is yours.
Yes, thank you very much, Michael. And if you want to see me, then exactly. So now I can start my video, and I will share also the screen. Just this presentation here. Okay. So thank you for the introduction, Michael, and thank you for the invitation. And so normally I'm talking in the IBC session, but as the IBC day was removed, I don't know why, I had to talk here, and I'm sitting in front of IBC Tower, Zebra Tower from SPIC in the Beijing headquarters. So IBC is continuing to become big, and maybe next time we will have also an IBC day. Let's see. So, but now let me tell something about our TopCon activities, because we have been working since many years now, for 5 years, also about on TopCon, but we have not many publications as we concentrated on processes which for industrialization, and that's why it will be, let's say, something new for you, I guess. So first of all, some slides about ISC Konstanz, about our technology transfers. Then I will tell you something about TopCon technology in general, but Shravan already gave a great overview. And then I will tell you about TOUCAN, which is another animal in our zoo at ISC Konstanz. And TOUCAN means tunneling contact underneath oxide on N-type. And then I will also tell you how TopCon can be improved in future, and also maybe have better bifaciality. And I will end up with a summary. So first of all, about ISC Konstanz, we are founded in 2005. And from that point on, from the very beginning, we specialized on N-type bifacial. So we are working on the future technology already since 16 years from the beginning. And our speciality is the technology transfer of Zebra and now also TopCon solar cells. And we are also transferring PERC if there is any need. So these are our cell concepts. We have talked about them on the first day. You talked about PERC, and we offer PERC technology transfer of 22.8. That seems, let's say, a little bit lower efficiency, but we always guarantee this efficiency in combination of Fraunhofer-ISE reference. So actually the efficiencies reported from Chinese producer are normally slightly higher. The TopCon, TOUCAN, we offer at 23.5 plus, and IBC at 23.8. And so these are our animals. Maybe you heard about Zebra, and now we have TOUCAN in our zoo. And the roadmap is quite clear, as everybody is having it. So PERC is now the king of energy markets, and it will remain, I believe, a longer time, the king the next 3 to 5 years. But then we move to the Emperor, to TopCon, heterojunction, IBC. Currently, our concepts which we are transferring are reaching voltages of 700 millivolt plus. And that's For our Zebra technology, we are not using any passivating contacts yet, but because of our advanced metallization, we can reach also 700. But for the TopCon, which is the topic of today, of course, we are using passivating contacts on the rear side, and we also use flat surface for a better passivation. But we are already working for concepts reaching higher voltages, like it is already possible for heterojunction, which will be then 720 millivolt plus. And one of those is TopCon with selective front polysilicon. Like maybe you know, there was a time of selective emitters for PERC, and the development ran into many directions. And this is what is happening also now for the front side of a TopCon cell in order to reach higher voltages. So about TopCon, very quickly, Shravan gave already a good overview that Jollywood is #1 producer and producing for a long time now, starting with LPCVD, now changing to other deposition technologies. And then PERC producers are mostly moving to TopCon, like you know it, Longi, Q-Cells, and Jinko. And Jinko announced the highest efficiency lately. And now, as I heard today, it was even topped by another consortium. What is not mentioned very often, because it starts now, is what is happening in India. And as you know, there are very large production linked in incentives, so-called PLI in India, and there are many companies. One of those, for example, Reliance or Tata, SSCL, Adani, and Avaada, and they have big plans on their roadmap going towards 3 to 5 gigawatt vertical integrated PV. Some of them will go most likely heterojunction, like Reliance, as we heard, but most of them will go PERC with the possibility to upgrade to TopCon. So already install a pilot line or even go into TopCon production. And recently I saw some announcement from Avaada that they are looking for partnerships, just for your knowledge. So if you have glass 400 tons per day, please contact Avaada. They are going to 5 gigawatt capacity. So these are glasses amounts. I am amazed how much you need for a 5 gigawatt production. Good, so this graph is quite well known that the capacity expenditures for N-type will grow in future, of course. And so PV Infolink is saying that there will be more TopCon out there, that heterojunction technology, and this is because of the fact that the PERC producers can more easily upgrade to TopCon, or let's say build new facilities because they know already the machines. And why they are changing to TopCon is clear, because PERC is coming now really to its efficiency limits that Q-Cells also was showing, and the Q-Cells development of TopCon technology is now overtaking their current PERC process, and that's why we are also very keen now to enter into the next generation. And so you can make calculations on how TopCon is improving, and as you know, it's a matter mostly of the voltage. So if you do all the calculations of front contact recombination, passivation, and rear contact, you came to the simulation results that the PERC is, let's say, limited to 685, maybe a little bit more. But then if you go to TopCon and you have a better passivated rear side, mostly you can go to 700 millivolt and to higher efficiencies. And but what will be the next step? This is not reported very broadly. Is if you go from TopCon then to selective passivating contacts on the front side, we call it selfie. Then you can of course increase the voltage towards 720 plus millivolt. And if you want to improve as well the bifaciality, then you can go also for selective polysilicon on the rear side. But this will be, let's say, the very last step to improve the efficiency and the bifaciality. So there are many announcements out there, and we heard it also from the heterojunction people that the frequency of announcements are getting more and more. So for example, at the beginning it was 24% PERC, but then we learned that actually that PERC already had polysilicon, selective polysilicon on the front side, similar to Jinko's TopCon, going to 25 plus. It's a matter of voltage, and we believe that there's also selective polysilicon already on the front side, and measured high fill factor from ISFH, for example, and this is also the case for the LONGi heterojunction. So as there are many announcements and many investors and people are confused about champion efficiency announcements versus industrial reality, we have now also written a PV international paper about it, which will come out, I think, next week. So you can read about it to, let's say, put the announcements and industrial reality in perspective. So here you see all the record efficiencies, and what actually matters is, as Shravan already said, available module efficiency on the market, where you have PERC at 21%, maybe slightly higher, and then the N-type technologies will go towards 22%, and then with selective poly on the front side, even towards 23%. So the TopCon 25.4, now we heard that it's 25.5 even, but the modules available on the market are now 21.4, becoming higher and higher towards 22%. And the efficiency potential in production is 24.5, as I pointed out, measured with the Fraunhofer-ISE reference. So back to industrial reality, PERC, we would say it's 23%, and we have done here cost of ownership calculations from the cell transformation, because the wafer prices are now extremely going up and down. So 4 cents per watt peak, higher for cell transformation for TopCon, of course, because of the complexity of the process, as you learned, and also because of the silver. Then higher also for heterojunction, not because of the complexity, maybe also because of the yield in production, but the silver costs are, and also the wafer costs are higher in this case, but the wafer costs are not included yet. And for our Zebra, it's somewhere in between. So as Shravan already mentioned, the switch from P to N is very comparable, like it was the switch from aluminum black surface field to PERC. It was, let's say, a matter of development of a machine, of low cost and good quality wafers, and also of pastes. And for PERC, it was the aluminum deposition, low cost ZZ wafers, but when LONGi brought the low cost ZZ on the market, then the switch was much easier, and that also the aluminum had to be adapted at that time. Now we have to go away from LPCVD to PECVD and also APCVD, which was not mentioned yet, but Schmid has a very powerful APCVD machine, and also PVD, which we are working on with von Adani. And of course, the N-type wafers has to be low cost and large area, but LONGi is very optimistic that they can do it. But the most crucial thing is now also the silver consumption, and not only to make the solar cells cost effective, but also when we enter 1 terawatt market quite soon in 2030, we must be prepared not to consume so much silver in the future. So here you see the process flows, which also Shravan was showing. You see that the PERC process is very lean, and also the heterojunction process. The old TopCon processes from Jollywood, Trina, Linyang were quite long. But now, let's say the newer TopCon process from Jollywood, and we will definitely hear about it because we have a nice lineup of people here, and Jollywood has now reduced the steps to very few steps because they are now using in situ doped PVD polysilicon, so they do not need the implantation anymore. But ISC Konstanz is also having very few steps because we are cooperating with Centrotherm on the PECVD in situ deposition. So now coming to our TOUCAN process as promised. So TOUCAN means Tunnel Oxide Under ContActs on N-type, developed in a publicly funded project. So we are already working since 5 years on passivating contacts for industry. So of course you need a boron diffusion. Every TopCon process needs a boron diffusion, and we have very much experience with that also because of our IBC process. So it's a homogeneous BBr3 emitter with aluminum oxide passivation. For our Zebra, we are not using aluminum oxide, we use the boron glass, but here, because of a better process order, we go also to aluminum oxide because it's much easier than to have the boron glass still on. And then we have, of course, the silicon oxide, thermosilicon oxide, and polysilicon, which I will go in more detail later. And then we have metallization with screen printing and firing through 9 bus bars. And our cell process at the beginning was LPCVD. Now we switch to PECVD polysilicon for technology transfer, but alternative processes are PVD and APCVD. So very important technology is, of course, the boron diffusion, and there we have a couple of patents and are using the Centrotherm equipment, low pressure BBr3 system, where it is also possible, but for TopCon not necessary, but it's possible also to have a very thin and homogeneous boron silicate glass with when you etch your glass, you can go to very homogeneous 15 nanometers thickness. But what is more important is, of course, the homogeneity of the boron itself, and it's really possible in the whole boat, in the large boat, to have homogeneous results. So polysilicon depositions, as has been mentioned, are extremely important. And if you say it's wraparound free, it's not. You still have a wraparound which you have to remove, but this is not a problem for phosphorus, at least with the RENA alkaline etch I will show you later. But our developments of TopCon and also selective polysilicon TopCon, which is a selfie, is based on PECVD, APCVD, and PVD. And our cell concepts can be only as good as the machine builders can provide their machines. And we are very lucky to sit in the middle of a very good machine building country. So Centrotherm von Adani and Schmid are doing amazing jobs to provide us with very good quality equipment. And we have publicly funded projects on PECVD, Popeye, Sputopia with PVD, and Hobbit on APCVD. And also metal recombination is extremely important. And on the front side, you see that with a metal fraction, you are of course decreasing the voltage, but on the rear side you are not, because you have this passivating contacts. So the idea is also to flatten out this curve later and to provide a selective polysilicon structure on the front side. Edge isolation and getting rid of the wraparound is also a very important topic. So we are using the RENA tool for alkaline single-siding etching, and which really leads to extremely good IV characteristic in reverse. So at minus 12 volt, 13 volt, for example, you have still only maximum 200 milliamps reverse. So some of the results of our TOUCAN process is that we have voltages of around 700 millivolt, and because in our lab, we are also processing still PERC and other technologies. Always during the technology transfer, when you produce megawatts of the same technology, this the voltage is increased. So we guarantee efficiency of 23.5% for our technology transfer in production. Copper screen printing is also a very important topic because it's not only plating that can make a difference. Plating is quite complex, and also the disposal is not very easy. That's why we are concentrating on copper plate screen printing, and we have reached a first 25 milligram silver zebra cell, and this technology we will then also transfer to TopCon, and there we are working together with Coprint with a special copper for that. So there was a presentation of Dominic Rudolph at the Metallization workshop November 2021. So everything is more or less okay, because if you screen print copper, of course, contamination could be a big issue, but we have blocking layers. But we still have to work on the adhesion, so the P4 is still very low. So coming now to something new is selfie technology, and here you can see already what is it about. So having polysilicon selectively with the boron diffusion only on one side, and the idea, which is a patent pending, is to process intrinsic polysilicon from a boron source and laser dope, and which serves actually as a etch resistant, and then you can etch down the polysilicon from not treated areas, and then you have more or less like a polysilicon, selective polysilicon on the front side. And this can be implemented into the standard TopCon or TOUCAN process just at the beginning, like what selective emitter have been also used, that we have an oxidization and e-poly boron source, which is done, for example, by PECVD, and then you have laser treatment, and with that you provide then the etch resistant. You can go to selective polysilicon. So my dream is, and I think this will become reality, that from 2025 plus, NPV will become the emperor. We will go to LCOE even below 1 cent per kilowatt hour, and that's not only because of the efficiency, but lower temperature coefficient, higher bifaciality, lower degradations. And this is actually already happening. So Jollywood, I think they will also show it later. They have now installed large PV systems already in Oman of 450 megawatt. And the advantage is clear. So you have lower temperature coefficient and higher bifaciality compared to PERC. So the bifaciality actually is, of course, higher than PERC, but of course lower than for heterojunction. And we have heard from Ryzen that they have installed 25 megawatt power plant. So it's a good start, let's say. And for this, we are organizing NPV workshops. We started already since 2011. So please visit us in Konstanz end of March next year. And we will also celebrate a 1 terawatt party with you. And we are also writing an NPV book, also with Jollywood, Longi, and other Chinese producers, similar to Beefy PV book that we have written in 2018. So coming to my summary, to have 3 takeaways. So I have shown you the TOUCAN route for low cost TopCon. We are offering a TOUCAN technology transfer at 23.5 plus with a one-sided PECVD polysilicon with high throughput. So Centrotherm is working very intensively to increase the throughput of the PECVD, and it seems to be extremely successful. PVD and APCVD are in progress, and APCVD we will of course use also for the front side for selfie. The copper metallization by screen printing is in progress. We still have to improve the adhesion. And TOUCAN's route for higher efficiency is of course the selectivity. And maybe also, if you do not want to be bordered with selectivity, you can go to IBC. But I'm sure that NPV will be the future impairer of energy markets. And with that, I would like to close my presentation and have a nice Christmas.
Thanks, Radovan. Very nice overview. I like your Zoom. That's very innovative. And also that it's getting bigger and bigger. If you have a few minutes to spare, I think it would be nice if you could answer some of the questions on the chat. In any case, we will see you later again for the panel. So let's continue with